Hello, you are welcome to Engineering Simplified channel. Today we are going to cover PLC basics they don't teach in school. And let's be honest, if you learn PLC in school, well, you probably learn ladder logic symbols like timers and counters and the likes. But when you walk into a real factory, things don't work the way textbooks showed you. So today I'm going to cover PLC basics they don't teach in school, but the industry expects you to know. Okay, so let's go there. And the first point we want to make here is that we want to say that PLC isn't just ladder logic. In school, we are taught, or PLC are rather taught like programming subjects only, but in real life, PLC are control systems, not just code, because your program is only part of the system, right? So things like sensors, wiring diagrams, actuators, safety circuits, process, understanding of these things matter, and the PLC scan cycles. So they matter just as the ladder logic we are focusing in school. All right, so having said that, we go to number 2 points. Well, we are taught that PLC inputs are just contacts, but I want to say that they are not just contacts. So one of the biggest confusion we have is that physical input versus PLC contacts are always misunderstood. Now, the physical input are the physical switches that we have in automation industry. Like you can see here, the little example I'm showing, you have the start button and the stop button. Not only these two buttons, you can also have things like emergency buttons, which we will cover in the later on. But the ladder logic program, which only represents this kind of buttons, like you see inside this box is the program, but outside these are the main keys, meaning that I can't just come inside its ladder logic and then manipulate the machine. Rather, for me, if I put start like a physical key push button, for example, in a motor, then that is the only when this start button inside PLC will receive a signal to give an output. And so on, so which we cover more. So what I'm just saying here is that a push button or sensor is a real hardware wired to the PLC. So a PLC contact is just software checking the memory bit. So you don't create switches in ladder logic, you read signals that already exist. All right, so let's proceed to the next point. Here we have the outputs aspect of it. Now I'm saying that outputs don't control load directly. So what do I mean? There must be an in between. You don't need to connect your PLC directly to your controller or your controlling device like motor or other systems. So there must be an interface, which could be a contactor like what you see here. Look at how the contactor is bridging the gap between the PLC and the motor. So the motor is not directly connected to the PLC. Rather, the outputs of the actuator or the output of the motor is connected to the actuator, while the actuator is communicating with the PLC. So we also have this type of connection where we have the variable speed drive or variable frequency drive if it is AC motor, but for DC motor and AC motor together, we can call them VSD, variable speed drive. So you can see that the PLC is not actually communicating directly to the motor, but it's communicating to the motor, or rather controlling the motor through this VFD, variable speed drive, and this variable speed drive is being powered by this miniature circuit breaker, while the PLC is being powered by this power supply. But the end goal is to control the the frequency, or rather the speed of this motor. So they don't tell, another thing they don't tell you actually is that PLC outputs usually don't power motors. That's what I'm saying, or heaters or valves directly, or any other controlling device. In industry, outputs control uses relays, contactors, VFD like you see here, or solenoid valve. So if you wire a motor straight to a PLC, you're on your own, so you will destroy the module. That's a very important point. So in terms of the scan cycle, scan cycle in industry actually explains most bugs or errors in our system. But before we dive into that, let's first of all speak on scan cycle. A scan cycle has this step, like you see. First, the PLC will read all the input signals or the input devices, and then compare it with a program, because you program PLC using ladder logic or any other language to suit whatever contact that's available in the industry. So the first scan is to scan the inputs and compare with the input with the program execution, which is your ladder logic or sequential function chart or whatever you might have in place. And now the next is to adjust the output based on the program, because the program and the input devices are speaking. If whatever you put in the rhyme, then the output should be controlled, or if not, an error might be returned. So we call this scan cycle, and this scan cycle has a specific time they use in doing the PLC uses in doing this. And the one thing with PLC is that it scans this line by line. So it goes from rung 1 to rung 2 to rung 3 and so on. So many beginners think PLC work like normal software, so they don't know that PLC run in scan cycle. So understanding this can also help you to know that if you prioritize your, or if you put the first run, know it that the PLC, the program must first run that one before going to the next. So it runs in sequence like that. So in other words, it reads the inputs, execute the logic, and update the output. So understand the scan cycle explains why latches work. In other videos, we're able to cover the idea of latches and sealing circuits. So, and also why signals look delayed and why order of logic matters. In terms of safety, in school project also, they in a school don't really also explain this correctly the way I'm going to do. I just want to push out everything at once, because in school projects safety is often ignored, like I said. So but in real plants, safety is of course everything, right? So things like emergency stop, safety relays, and safety PLCs often work outside your main logic. So meaning that you need to create a particular program that represents the safety of that your system, right? So sometimes it might be too clumsy for you to put them in the main logic or in the main program. So there should be a separate program also for safety. All right. So you don't just program safety, you design it, and it must be real. Okay, so that's part of the thing that they don't cover in school. Okay, so moving on, we have other aspects, that is PLC programs meant to be maintained. And what does that mean? In school, your program only needs to, you only need to pass exam once you put your program correctly and the lecturer will mark, that's it. But in industry, we are going beyond that. There are supposed to be some maintenance. You need to maintain something like clearing the tag names. It matters a lot, and commenting while programming, like what we see here Of course, in most of PLC platform, we've got tag names. Okay, so and also comment to label so that anytime you want to use that tag, you don't have to use it anymore because you've used it already. And it helps us to identify our contacts, be it the coil or the input contacts or whatever contact you might be labeling. So if it also the data type matters because you can't send Boolean to data type like time or maybe data type like long and so on. So if it is Boolean, it's Boolean. So the addresses like that's what we call tag, of course, they matters a lot, and also the comments. So a working PLC program is not always a good PLC program. Therefore, PLC programs are meant to be maintained by following this. All right, so I hope that is clear. I believe so. Now, another aspect, like what you normally focus in school is simulation, because most of the time, some of our schools don't have the necessary equipment to mimic the actual industrial equipment. So we end up leveraging simulation softwares. So what I'm saying here now is that simulation is not real word, or is not the real world, or does not actually represent the 100% of what is happening in the real world. So simulations are great for learning, but the real systems have noise, faulty sensors, loose wiring, human error. So a real PLC engineer learns to troubleshoot, not just program. So that is another thing that you need to understand so we can bridge the gap between the industrial experience and the school knowledge. Okay, so you must be accounted, or this must be accounted for, rather, noise, fault sensors, human error, loose wiring, and so on. Okay, so that's point being made. So another one is operators matter than even programmers and than the code. So somebody that is going to operate the system day by day matters a lot. All right, so in school, machines are perfect. In real life, operators are part of the system, and they must understand your program. So because sometimes they can bypass the sensors, they reset alarms without reading them, they override logic to keep production moving. So good PLC programmers should expect this kind of behavior from operators. So they design systems that guide operators, protect equipment, and prevent dangerous behavior. So if operators constantly fight your system, then your design has failed. So these are the things that are not being taught in schools. All right. So what should, or what you should do, or what you should actually focus on as a programmer? You are programming and you're also thinking of the industry. First, as a programmer and a PLC operator, you need to understand machines. Focus more in understanding machines than programming. Understand electrical fundamentals, simple circuit theorems, and so on. Understand how to read drawings, troubleshooting under pressure, writing readable code, and communicating with maintenance and operators. So these are extra features that are not often covered in school. All right, so if you want to succeed with PLC, you should focus on these things. And PLC programming is not just software. It is actually industrial problem solving day to day. So production systems on factories, everyday activities in industries, they all use PLC. Okay, so in concluding remark, if you want to succeed, like I said with PLC, don't just learn symbols, learn how systems behave. So if school taught you PLC syntax, that's a great start. I'm not disputing that, but industry teaches responsibility, troubleshooting, and process thinking. So PLC aren't just logic, they are the backbone of modern industry. So if you want more videos like this, please subscribe, like, share, and tell me what topic should be next, because these are the stuffs they don't teach in school. Please don't forget to subscribe.